Hello and welcome. In this video, we'll look at Congruent Standard 9 from the Common Core Standards for Geometry. The standard here is to be able to prove theorems about lines and angles. Four specific theorems are mentioned, but this video will focus on that first theorem, which says that vertical angles are congruent. So let's learn some things about vertical angles. Before we get started, one piece of background knowledge that will be important in this discussion is to know that one full turn represents 360 degrees, and so a half a turn should represent half as much as 360 degrees. Well, half of 360 is 180 degrees. So if the sides of an angle are on a straight line, then the angle should be 180 degrees. Just keep that in mind as we go forward. The diagram for this discussion is extremely simple. We just have two lines that intersect each other. Notice that when they do that, they form four angles. And the goal of this conversation should be to determine relationships amongst the measures of these four angles. Let's just quickly name some things so we understand some vocabulary. Two angles that share a vertex and which are next to each other are called adjacent angles. Adjacent just means next to. So for example, 3 and 4 are adjacent angles, 1 and 2 are adjacent angles, and I'll challenge you to find two other pairs of adjacent angles in this figure. Besides adjacent angles, we have pairs like this one. These two angles share a vertex, but they don't share sides. In fact, they're opposite from each other. Similarly, 2 and 4 share a vertex, but are opposite from each other. And these are what we call vertical angles. So again, 1 and 3 are called vertical angles, and also 2 and 4 are called vertical angles. If it helps you understand the vocabulary, you should know that the term vertical is derived from the term vertex. So vertical angles share a vertex, they're formed by intersecting lines, and they're opposite from each other. Let's see what we can learn about vertical angles. Let me just wheel out my protractor here, and I'll set the protractor so that it aligns with the vertex where the lines intersect. And let me just rotate this protractor around so that the 0 marker aligns with this line right here. Okay. So let me go ahead and take my marker here, and I'll rotate this point around until it lines up with that other line. Change of color. Let's rotate this line around until it ends up on this line. And let's keep on rotating around to this line. Last rotation. We'll go all the way back around to where we started. Now, how many degrees is that all together? Well, we made one complete turn, and you can see right here on my protractor the number 360. So all four of these angles together should make 360. That's one important thing to know. Now let's actually measure one of these angles. I'm going to rotate this again so that the 0 marker now aligns with this line. And I'm going to attempt to measure, get it right on there, I'm going to attempt to measure the green angle at the top there. So let's count. The green angle goes through 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140. It's more than 140 degrees. It's less than 150 degrees. It's approximately equal to 145 degrees. So I'm just going to write that in here. Oops. And there we have it. Let me close out my compass for a minute, protractor rather. I wonder if it's possible to determine, using math reasoning, knowing just one of the angles, can we figure out the measures of these other three angles? Let's give it a go and see what we can come up with. So one observation we can make about the figure is that when we turn through the green angle and then through the purple angle, we've made exactly half a turn. And we know that because those two angles make up a straight line. Half a turn is 180, so we would expect that the green angle plus the purple angle should make 180 altogether. 145 plus something for the purple angle should equal 180. Let's see if we can solve this. A little mathematics about to happen here. If we count up to 150, we have to go 5 degrees, and if we count from 150 to 180, that would be 30 degrees away. And so altogether, we've traveled 35 degrees to get from 145 to 180. So the answer is 35. In other words, the measure of the purple angle is 35 degrees. Splendid. Let's see if we can continue doing math reasoning to figure out the red angle. Well, the red angle also represents a half a turn together with the green angle because they form a straight line. So green and red together also make 180. So starting with the green, we need to add something for the red to make 180. Starting from 145, we need to get to 180. How much do we have to add? That sounds an awful lot like a problem we've just solved, and the answer was 35. So the answer must still be 35. The red angle is 35 degrees. Notice that the red and the purple angles are exactly the same. And if you followed the reasoning here, you should understand why. Let's continue by finding the measure of the orange angle. We can go about this in one of two ways. We can notice that the red plus the orange make a straight line. So that's half a turn, which is 180. Or we could notice that the purple plus the orange also make a straight line. Also half a turn, also 180. Either way you cut it, we need to start with, let's say the purple for example, we need to start with 35 and we need to add something to get to 180. Well gosh, all the mathematics is right up here in this equation. It's just turned around. So this time we started with 135, but apparently we need to add 145 to get to 180, so that must be the answer. Notice again, there's a relationship between these vertical angles. They're both equal to 145. Let's try that reasoning again, a little faster this time, but rather than starting with 145, I'll start with 150. Here goes. The green together with the purple make a straight line, so we need to add the amount that will take us to 180. The answer is 30. The green together with the red make a straight line. Again, we need 30 to take us to 180. Red plus orange must be 180, so this must be 150. It seems awfully compelling to conclude that each pair of vertical angles, 30, 30, 150, 150, must be congruent to each other. In fact, let's try to prove that that's the case. When we're doing a proof, we can't choose a particular number because then we wouldn't know what's going on with all the other numbers. So we're going to have to use variables here and do a little bit of algebra. Let's get started. Okay, so I've labeled the purple angle W, the green angle is X, and the red angle is Y. Notice W and Y are vertical angles, and we'd like to prove they're congruent. So our goal is now to show that W is equal to Y. In order to do that, we'll just review the observations we made earlier. The purple angle and the green angle together make half a turn, so W plus X should be equal to 180. When writing a proof, it's just a matter of being very clear about your reasoning and laying down the reasons for the things that you know. So how do we know that W plus X makes 180? Well, it's because those two angles make half a turn, since they make up a straight line. The second thing we did was we said that the green angle plus the red angle are also half a turn, so X and Y must be 180 as well. X and Y make 180 because they too make half a turn. This next step requires a little bit of discussion. If you've never done this before, it can be just a little bit tricky, so let's just slow down and think about what we can learn from these two statements together. We know W plus X is equal to 180. We we know y plus x is also equal to 180. If I told you that Joe weighs 180 pounds and Tom weighs 180 pounds, couldn't you conclude that Joe and Tom are the same weight? Of course you could. And in the same way, if w plus x is 180 and y plus x is 180, we can include that w plus x and y plus x are equal to each other, because they both equal 180. That makes a lot of sense. This kind of reasoning is used so often, mathematicians have given it the name transitive property, but it really is just common sense. The transitive property says if two things are equal to the same thing, then they must be equal to each other. I get it. Okay, so with that, we have these two quantities equaling 180, and so they must equal each other. We could explain that by saying both of these things are equal to a half turn. That's why they equal each other. Lastly, if we subtract x from the left side of the equation, we'd be left with w. If we subtract x from the right side of the equation, we'll be left with y. And so w must be equal to y. Right there, I've used the subtraction principle, which says if you subtract the same thing from both sides of an equation, then the results must be equal. Think of it as canceling the x's. And there we have it, w equals y. That was our goal, to show that vertical angles are congruent, and we have done it. Splendid. Here's a challenge for you. Try to write out a similar proof to show that x is equal to z. And be very, very explicit in your reasoning. Be sure to link your statements to your reason with the word because, and give it a go. Have fun. I hope that helps you understand the vertical angles theorem and how to prove it. Thanks for watching.